So now let's talk about shifting graphs. So if you have a function and you have a constant added at the end of the function, then you know you're shifting your graph up or down. For example, if we looked at y equals x squared, we know that that is a parabola, and that parabola opens up. But if I were then to say x squared plus 2, it would be exactly the same parabola, only 2 steps higher on the graph. If that were a minus 2, it would be 2 steps lower on the graph. So remember that the original parabola would look like this. Right? But that would no longer be the case now, because if I'm going to graph plus 2, the vertex would move up 2 places, and all of the other points would move up 2 places as well. And so this is what the parabola now looks like, right? So if you have a plus or minus something added to your function, then you know that it's going up or down. Horizontal shifting. That's when you have an x plus or minus something on the inside of parentheses. So again, if I were to look at y equals x squared, that would be a parabola. But if I was asked to draw y equals x plus 2 squared, that would now take the original parabola and it would move it to the left 2. Now I know it's a positive 2, but when we have things on the inside of the function, it always moves in the opposite direction than we think. So whereas the original vertex for y equals x squared would be 0, 0, now it's going to be negative 2, 0. That's the vertex of the parabola. And the parabola would be exactly the same width, just that it is further over. So again, if that were plus 2 or a minus 2, it would have been on the right side instead of the left. Vertical stretching. This is when the shape of the parabola changes. So if I took the original y equals x squared and I put a 2 in front of it, it would just make it stretch vertically. Which kind of makes sense, because if x is 0, y is still 0, but when x is 1, now y is 2. And when x is 2, instead of it originally being 4, it's now 8. So it is vertically stretched. If that 2 were a half, it would vertically shrink it. Horizontal stretch. So it's a little bit harder to see with a parabola, but if I were to put a 2 on the inside of this function, it makes a horizontal shrink. It's the opposite from the way it appears. So why is it a horizontal shrink? Well, because if you think about it, if you were to do out that square, it would come out to be 4x squared, which could also be looked at as a vertical stretch. But instead of looking at it as a vertical stretch, because it's on the inside of the parentheses originally, it is a horizontal shrink. So originally, the points were out here, and everything is shrinking in. Reflection around the x-axis occurs when you have a negative in the front of the function. What does a reflection mean? It means that instead of this parabola opening up, it is reflected down around the x-axis. It is now opening down. Reflection around the y-axis occurs when you have a negative on the inside of the function, which is hard to see with a parabola, because when you're reflecting around the y-axis, if you think about a parabola here, 0, 0 reflected still 0, 0. 1, 1 would be reflected over here. Negative 1, 1 would be reflected over here. So reflection here doesn't really change anything, which again kind of makes sense, because if you did out the square, what would happen? You would end up with a positive. So that's the basics of all the shifting and translating, as they call it, and the stretching or shrinking. So I'm going to just do a couple more examples with you. In this particular case, first of all, the vertex, this is a V shape. I know it's a V shape because it has absolute values. The vertex of the V shape would occur where 1 minus x equals 0, or where x is equal to 1. And when you substitute 1 back in, you know the y value is negative 1. So the vertex of this is 1, negative 1. The second thing is that this is going to actually be reflected around the y-axis. However, what I'm going to do is make a table of values, because you guys probably remember, anytime that you're stuck, you can always make a table of values. So when x is 0, if you substitute 0 in, you get 0 for an answer. When you substitute 2 in, you get 0 for an answer. When you substitute negative 1 in, you get 1 for an answer. And I can see the V shape forming. Okay? So again, that's a reflection around the y-axis, not the x-axis. That's why it's opening up. So on this next one, there's a couple of things that need to be done. First of all, we know that we need to go up 1, and we also need a reflection around the y-axis. Sorry, x-axis. Because the negative is outside of the square root. So, which one of those two things do you do first? Well, because the negative is in front of the function, you're going to do that piece of it first. Think about your order of operations, right? Multiplication comes before addition. So the negative comes first because it's in front of the function. So let's start off with, first of all, looking at what does the original function look like. So what does y equals square root of x look like? 0, 0, 1, 1, 4, 2. Okay, now let's reflect it. So let's do this negative piece. So now I'm going to reflect it. Okay, now I'm going to take that whole thing and I'm going to shift it up 1. Now, if you want to double check to see if your final answer is correct, you just need to make a table of values. So when x is 0, y is 1. When x is 1, y is 0. When x is 4, y is negative 1. So I know that I have the correct graph above. Lastly, I know that if this graph were to be y equals 1 over x, I know that that would have a horizontal asymptote and a vertical asymptote. And I know that the graph would follow those asymptotes. However, it's got a +2 on the bottom. So there's a +2 on the inside of the function. So what that tells you is that every point now is going to move to the left 2 places. So that means that my vertical asymptote now is going to be over here at -2. That does not change the horizontal asymptote. And so now I know that my graph is going to look like this. Because everything is being shifted to the left too. Okay, take a look at these 8 problems and decide what you think that it might do to the graph. So pause the video and see if you can figure out what each one would do to the graph. Okay, take a look at these answers and see if you got the exact same thing. Again, you may want to pause and reflect on my answers and compare them to yours. Now, one of the things that you may wonder about is, like, why did E reflect around the y-axis and then go to the right 2? When it's a plus 2, why wouldn't it go to the left 2? Well, again, remember that on E, you're supposed to take this stuff that's on the inside of the function, set it equal to 0, and then that tells you if you're moving left or right, is according to if it's positive or negative. So what does this mean up above? Well, let's graph E up above and we can see what happens. So first of all, I want to take this graph and I want to reflect it around the y-axis. So if I reflect that around the y-axis, that piece of it will look like this. Okay, now I'm going to move everything to the right 2 places. So this would go 2 places, this would go 2 places, this would go 2 places, and now it will look like this. So that would be your final answer for E. Let's take another one for an example. If you were going to graph, say, H, you're going to go to the right 4 places. I'm imagining where 4 places might be. This is going to go to the right 4 places, and this is going to go to the right 4 places. Okay, so that's taking care of the right 4 places. And then we're reflecting around the x-axis. So this reflection stays, that reflection goes up, and now it looks like that. So that would be letter H. Right 4 places, reflecting around the x-axis. Okay, if you have any questions, please let me know.